Atwood's machine consists of two masses connected by a string that passes over a pulley, as shown in this figure. In the specific case where M1 equals 3.1 kilogram, which is this block, and M2 equals 6.4 kilogram, which is this block. We have to find the acceleration of these masses. Consider Newton's law of force. Sum of the forces equals the sum of the masses times acceleration. And if we're looking for acceleration, we'll just move these variables around. We'll get acceleration equal to the sum of the forces over the sum of the masses. The sum of these two masses is going to equal to 9.5 kilograms. Now the sum of the forces we're going to derive from the forces acting on the blocks. Now essentially the only forces that we're going to have acting on the blocks are going to be the forces of these weights, and of course some upward and downward tensional forces that meet at this pulley. So given that we have these tensional forces from this string that's tied to both of the blocks, one force is pulling against another force. We're going to have two forces counteracting each other. However, one's going to be greater than the other. And in this case, these tensional forces are directly proportional to the weight of the blocks. Mass 2 will have the greater influence. We'll consider this tensional force to be positive and this downward tensional force to be negative. So let's find our acceleration. Now, since these two blocks are tethered together, they're going to share the same acceleration. So our only acceleration is going to equal to this force plus this force. And give consideration that this is going to be a positive force and this is going to be a negative force. So I'm going to start by subtracting the mass with the lesser influence from the mass with the greater influence. And since we're focused on weight, I'm going to multiply these two by gravity, which is 9.8 meters per second. But for our own convenience, I'm going to consider it 10 meters per second squared. Now let's get rid of these signs. This kilogram on the denominator will cancel these 2 kilograms on the numerator, and we're going to be left with just meters per second squared, which is the appropriate units for acceleration. Our answer for acceleration in 3 significant figures will be 3.47 meters per second squared. And here is our answer. And again, there is only one acceleration because both masses are tied together.